Good afternoon, everybody. This is Bart from multirotorforums.com. I've started a new build. I'm building a Hexacopter, and the plan is to use it to carry a Zenmuse, a DJI Zenmuse gimbal for a Panasonic GH3 camera. And what I'm doing today, there's the camera, just to fill the frame with something. What I'm going to do in this video is just give you an idea of how I start a build, how I plan it, what steps I undertake in order to get a rough idea of whether or not the design that I'm planning actually has merit. So to that end, I'll just put this up in the corner here. What I do is I start out by roughing out the weights of the components I know that I'm using, and I try to get an idea of what the total weight is going to be approximately, and then I use that weight to figure out the number of motors that I might like to use, and whether or not the motors and props and battery selections that I've made are going to be usable. If I'm very far off the mark, I've got a cold, so excuse me, I'm a little rough in the voice today, but what I do is a couple of iterations where I might make some changes to see if things work or don't work, and I try to hone in on a plan, on a set of components that will work well together and that will fly my helicopter around efficiently without being too large or too heavy for the particular piece of equipment that I might be trying to carry. So you try to get everything as close as possible to being optimized. Now, with this particular build, I know that I'm going to use KDE's, I believe this is the it's the KDE 4012 or 4012 XF 400 kV motor. I also know that I'm going to be using Turnigy Nanotech 8000 milliamp 6-cell battery packs. So a couple of things are pretty well written in stone with this build, and so the steps that I'm going to go through here are to make sure that I can come up with a workable solution around these particular components. So right now I know I'm going to be using these batteries, I know I'm going to be using these motors, I know I'm using this camera, and I know that I'm going to be using this camera mount, which is the Zenmuse for the GH3, and I know that I'm going to be using DJI's A2 flight control system. So how do I make this all into a workable plan for a new helicopter? And that's what we're going to discuss. So first I make a list of the componentry that I'm expecting to have on the helicopter. So we start with the frame. Then to the frame we have to add great that I can spell the word motors. Motors doesn't start with a T in my language. Anyway, motors. With the motors we have ESCs. Okay, and then the frame, the weight that I'm specifying for the frame does not include retractable landing gear, which is a necessity if you're going to have a 3-axis camera mount. So we've got a separate line item for landing gear. Then we also have the batteries that I mentioned before. We also have the flight control system. There's going to be some RC related gear, like a receiver and some wires. We are going to have a video transmitter. We'll also have the camera mount. And the camera itself, our GH3, And also with the motors we'll put props. Okay, so looking at this laundry list of details, anything that we miss, anything that we think we might have to add a little extra for, we'll call it miscellaneous. Okay, so for the frame we've got about 600, and that's going to be grams. For the motors and props, we've got about, the motors are about 205 each, and 5 times, we're looking at a hexacopter. So the motors are going to be about 1230. The props are going to be about 20 grams a piece, so that's about 120. So we're looking at about 1350. And I'm just keeping a tally over here on my laptop so that I can come up with quick numbers as I'm talking. ESCs are about 40 grams each, so that's 240. And I'm doing all this based on the assumption that I'm going to make a hexacopter. If I do this and the numbers come out all wrong, I'm going to have to come up with a different estimate for number of motors, or I'm going to have to come up with a different estimate for my propellers. I might have to assume I'm going to use smaller batteries. I'm going to have to make some tweaks, but right now I'm pretty sure this is going to be a good plan for a hexacopter. So the landing gear, I'm using RC timer landing gear components. I'm modifying them to fit my frame, but I know the components I'm using are a little over 600 grams. Okay, the batteries, 2 of them weigh 2270. And let's see, the flight control system, if you go to DJI's website, it's about 230. RC gear, I've just given that a ballpark number of about 50 grams. Same thing with the video transmitter, about 50. Let me just put some of these numbers in. I'm tweaking some of these numbers upward as I go from my original ballparks. The camera mount with my added bracketry to attach it to my frame weighs 1300, and the GH3 with the lens that it needs to have for the camera mount, that's 710. Okay, so miscellaneous could be anything from zip ties and Velcro to wires, little additional doodads that you might have to put on the helicopter. And when all that stuff adds up, I mean, we can call it 75 grams just to have a number that's workable. So let me just double check everything to make sure my math is the same on my spreadsheet as it is here. 230, 75 for miscellaneous, 50, 50, 1310. So the total for all of this, okay, is 7485 grams. Okay, 7485 is about 16.5 pounds, and 16.5 pounds divided by 6 is about 2.75 pounds per motor. Okay, now that's a great number to know, because what I want to establish is, when I'm hovering, how much is each motor going to be lifting, because I can go to the website for KDE and look at their charts and very quickly determine where this motor is going to be in its operating range when it's producing 2.75 pounds of lift. Ideally, I would like to use a 14 to a 16-inch prop. So if I go to the KDE website, and I looked at all this already, so I'm pretty sure of what I'm doing, and I know the numbers are going to work out pretty well, but I just wanted to go through this. I'm actually running these motors a little bit on the lower end of their range. They can make a lot more lift than I'm using them to make. So if I wanted to go to smaller motors, I could save a little bit of weight and probably improve efficiency just a little bit. But I have these motors, they're good quality motors, I wanted to use them on something. And there is always the possibility this hex is going to have to carry a little more weight due to other stuff being added to it. You know, an HD wireless system, you know, like a Teradek or something. But right now, if I use 14-inch props, and I need to make about 2.75, that puts me right around 63% of thrust with 14s. And if I use 15-inch props to make that much thrust, it puts me right about 50%. Now I have 15-inch props. I'm happy to cut them down to 14 or 14 and a half to kind of tweak the flying qualities. I'm making the frame to be usable up to 16-inch props. Now that was a design decision I had to make in the planning process. I might scale it back a little bit. I might cut the arms a little bit shorter. That'll make the overall size of the helicopter a little bit smaller, and maybe I only need to make it good for up to 15-inch props. But for the most part, I think all my numbers are pretty accurate. I think I'm probably going to come in pretty close weight-wise using these numbers. And ideally, you know, with DJI, it's a DJI A2. And typically what I've seen of DJI is they like, DJI flight controllers like the props to be a little smaller and the motor's spinning a little bit faster. And you get a more stable helicopter that way with DJI. So I'm happy to run 14-inch props at 65%. And I'm happy to know that if my estimate holds up and I come in right at the weight that I've calculated, I could add much bigger batteries, have a lot of room to go to 15-inch props, and then I'll be running maybe at 60%, which is still pretty good. So all in all, I think this is a good plan. I'm going to go ahead and build it this way, and that's where we'll pick up. Thank you for watching. And thank you also for participating at multirotorforums.com.